Multiplying and dividing numbers in scientific notation. Chapter 2, Lesson 3. Much like multiplying and dividing fractions, this is actually easier than adding and subtracting the exponents. So take a deep breath, you'll do fine. So when we're multiplying numbers in scientific notation, we're actually going to be using our product of power property that you learned in the last chapter. So all you have to do when multiplying is simply group our numbers together. First, you're going to group your coefficients here, 5.8 and 2.5, and then you group your powers of 10, and then you're just doing the multiplying. 5.8 times 2.5 would be 14.5. And don't worry, I'll let you use a calculator. You're going to then move this decimal over so it's back in scientific notation. So that's where this 10 to the first power comes from. So you have 1.45 times 10 to the first times 10 to the third times 10 to the third. So we're adding all our exponents together in the product of powers property. So we get 1.45 times 10 to the 7th. Again, I'll let you use a calculator. I'm going to be using a calculator while going through this lesson. So no, I'm not pulling these numbers out of thin air. But again, you're using the product of powers for the exponents here and just simply multiplying your coefficients. And then only moving a decimal to get something back in scientific notation. So let's try this example here. We have an E. coli bacterium that has a measures 4 by 10 to the negative third, and then a length of 2.3 times 10 to the negative third. So we're just going to use the commutative property to group our numbers, our coefficients of 4 and 2.3, and then our numbers with our exponents. And now we're going to multiply our coefficients. So 4 times 2.3 is 9.2 times 10 to the negative third times 10 to the negative third. Since 9.2 is greater than 1 and less than 10, I'm going to leave it alone. So 9.2 times 10 to the negative third minus 3 would simply be 9.2 times 10 to the negative 6 power. Again, much simpler here than adding or subtracting. So let's try these examples here. We're just going to, we have 5.8 times 10 to the 5th times 1.5 times 10 squared. It doesn't matter that we have different exponents, not at all. So I'm just going to regroup so that my coefficients are together and my exponents. So now I'm going to do my multiplication. 5.8 times 1.5, again I'm using a calculator, is 8.7 times 10 to the 5th, and I'm using product of powers to add my exponents. Since this is already greater than 1 less than 10, so I get 8.7 times 10 to the 7th power. Number 3, 8.25, I'm grouping with 7.8 times 10 to the negative 6 times 10 to the 8th power. So 8.25 times 7.8 equals 64.35. So now this time I have to move my decimal over 1, so I'm going to include 6.435 times 10 to the first power times 10 to the negative 6 times 10 to the 8th. And I'm combining all my coefficients here, 1, negative 6, and 8. 1 plus negative 6 is negative 5. Negative 5 plus 8 is 3. So I would have 6.4. They said round to the nearest tenth, so I'm leaving that alone, times 10 to the third power. So I want you to try these on this page. Click pause, give them a try, and then come back and check your answers and check your work against mine. So pause now, please. And I'm grouping my coefficients and then my exponents. Then I multiply. In this example, I have to move my decimal. So I get 2.475. Since I moved my decimal, I have to include that. Oop. And I'm going to just add my exponents. Product of power, 1 plus 2 plus 2 is 5. So my final answer is 2.475 times 10 to the 5th. So this one is area, so I'm multiplying it by itself. This is already in scientific notation, so I'm just adding my exponents. And then this one is again another area, so I'm just grouping my coefficients and then my exponents. (7.7) times 10 squared times 10 to the first. Again, product of powers gives me 7.7 times 10 to the third power. So I bet you got all these right. Keep on going. So we can also use the quotient of powers when dividing numbers in scientific notation. So we're simply just doing the division. We're grouping our coefficients, 7.5 divided by 4.9. And then the quotient of powers property. So we're subtracting our exponents. So 1.5 times 10 to the 5th minus 3 would be 1.5 times 10 squared. They actually evaluated it and made it 150 because that would be 1.5 times 100. Okay, so you're just dividing here your coefficients and then using the quotient of power property here to do that. So let's do some practice. So in this case, we have 1.1 times 10 to the third. This is the thickness of a storybook, and 2.9 times 10 to the third is the thickness of a dictionary. So they want to know how many times bigger. So I'm going to do 2.9 times 10 to the third divided by 1.1 times 10 to the third. Again, I'm separating my coefficients. 1.1, 10 to the third, 10 to the third. So 2.9 divided by 1.1 is approximately 2.6. I'm just rounding to the 10th. And then 10 to the third minus the third is 2.6 times 10 to the 0 power, which anything to the 0 power, remember, equals 1. So this is simply 2.6 times greater. Okay, we don't even need to put that in exponent form because it's just 2.6. So why don't you give these two a shot on your own for me and then come back and check your answers and check your work with me. Okay, I want to make a correction on this one over here. I apologize. I did -3 minus 4. It should have been -3 minus a -4. So this actually is 2 times 10 to the first power. Sorry about that. But you've reached the end of chapter 2. You've done a great job. Remember, you can look back on any video anytime.